All right, so hopefully you had a good weekend. Want to talk and address something. There's been a little bit of confusion with you all in 8th period. We'll make sure you understand. Tomorrow is not your quiz. It's next Tuesday is the quiz.
Oh, I feel so bad for y'all having all this. Oh, crap.
So, heads up. Be studying for that quiz. I absolutely love getting into this section and stuff that we're going to talk about. Yes?
I haven't been here in like 2 weeks, so I'm really confused.
So watch the videos. Someone's mom.
She's been sick.
Hours.
I haven't been
So you're telling me she was sick and she's sitting there? She wasn't staring at her phone? I know when I'm sick, I sit there on my phone.
Well,
That's
I
fine.
forgot.
You got the videos you can watch. You got me, you can come ask questions too. Do you got evening trade school?
Yes, I have been.
Okay, so you got first lunch you can come in a little bit for if you want to do that. I got seminar then. Then, what's your schedule like? What you got second period?
Next period I have Miss Lester.
That's not happening. Third?
Miss Gilman.
Fourth?
Miss Cole.
Doomed, I tell you, doomed.
Find some time, ask me some questions, watch the videos. Very, very important. Watch the videos because there's like one day in particular I covered some stuff, introduced some really confusing stuff, and really like smack you in the face with the 2x4 stuff that you need to understand and be able to explain. And if you can't, we're in trouble. So please, 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 please watch videos, ask me questions. I will work with you. I don't expect you to take it next Tuesday. My advice to you is to study, get yourself ready, and take it before Thanksgiving break. Because every time I see kids that push off, and this goes for everyone in this room, anytime you take a quiz and you just keep pushing it off, every day you push it off, you do worse. So you got to find a balance in that. Just being honest with you. Okay, so Friday, we left off, you guys got to do the lab.
Yes.
I know that wasn't like super exciting, but this is the purpose of that lab. I want you to get an understanding of what's going on. So, we introduced you into some ideas that you already knew, but hopefully you can draw relationships with them now. So you calculate the average atomic mass of an element. Atomic number 119, not really, JK, but benium. So to do that, I gave you different types of beans. I gave you different types of beans on purpose. The different types of beans are there to get your idea wrapped around. All these beans I gave you, the cranberry, black beans, lima beans, and the red kidney beans, they are all different shapes and sizes. What do they all have in common? They're beans. What's the difference? The masses. What's that relationship with? Average atomic mass. Those are our isotopes. These are our isotopes. This is the way to look at this. I do this so it'll stay in your mind. It needs to stay there. The reason it needs to stay there is because it's going to come back. You remember that message I sent y'all on Remind? Corey Hatfield sent me? I just finished solving a problem in chemistry that involved everything that I've learned in chemistry. That's what I'm preparing you for. So when you get to college and they give you that question, you laugh in their face and you look and say, this is the best you got? I had Hall. This is a joke. Come at me with something.
I do conversions in my sleep. No calculator.
You can get into the salty
Scoop
spoon.
method.
So this is what we had to do. So whenever you're doing average atomic mass calculations, you need two pieces of information, right? You need the mass of the element of their isotopes. So we did an average for that. And I just guessed numbers. These are not the numbers you're actually going to get, These are somewhere around something or another. So up here with the, bless you, the cranberry bean. You had 7 of them, but I wanted an average mass for it. So I took 4.4 divided by 7. I got an average mass of it. So approximately every cranberry bean should be around 0.6286 grams. I'm not telling you that's true or not. Remember, these are numbers that I literally just pulled out of my head. Another piece of information you need is a percent abundance. The percent abundance is based on the idea and the fact of how much of that element is that isotope. So you had to find some percentages. So we did that. We took the number of the bean and divided it by the total. Once we divide it by the total, we would get the percentage. But can you multiply by the percentage? Somebody say no.
No.
Thank you. I tell you what, everybody needs some coffee this morning.
I don't like coffee.
I don't care. You still need coffee. Y'all are like blah, like extra blah today. This is a class that's normally like, woo!
It's one of them weeks, man. One of them
Blame
weeks.
this.
I blame the
Yeah.
time. I blame time change.
And the other test that I got today. Blame that too. Yeah.
Good.
No.
Good teachers are making you strong.
No,
Like
they're making
sad.
me depressed.
No, no depression. Okay. Doing an average atomic mass calculation. You set it up. You multiply the mass by the decimal of the percent abundance, right? So cranberry beans first, 6286 grams times the percent abundance, but it has to be the decimal. So I hear Miss Cole yelling at me right now to do the scoop method. Boom, boom. Take the decimal, slide it 2 places to the left, you now have the decimal of the percent. Everybody good with that? Or you can do what I like to do, divide by 100.
Same thing.
I love how it is. It's like before I get you all, the math teachers have had you, and it's like you walk the plank that they walk. And don't you dare venture from it. It's always fun when we get to physics and I'm like doing stuff like, why don't you just plug all the numbers in and solve for what is left? I don't know, there's a science way of doing it. That's what I've came up with. Anyway, we add to it the rest of them. So now I've got the black bean. Math, 0.65 grams times the decimal of the percent abundance. Plus lima bean, 2.9 grams times 0.1579 plus red kidney bean, 1.24 grams. Oh man. Hold on a second, I feel my phone vibrating. I know what this means.
Mr. Hello, you
Yes, I
forgot
did.
again.
I did. I'm alive.
I did. Y'all gonna have to start reminding me to ask me every day. Did you message Mary? And you all can message her. Funny thing would be if one of y'all start messaging her. Mr. Hall made it, by the way.
Send me a calculator.
Actually, how are you gonna remind that?
Yeah.
So when we get there, she needs to set up some reminders every morning. So when you get here, just don't remind her to message.
I get so caught up in what I'm doing,
Is that a time? Is that an alarm?
I'd ignore it too. Sometimes, man, I get stuck. Like, I think it drives her nuts that I'll get stuck in what I'm doing and I'll totally forget. But then I get so mad if she's driving somewhere without me and doesn't tell me. It's weird. Alright, so I do this and I get the average mass of 1.1527 grams. That is what your lab was on Friday. So this is one of those that we were doing to check your knowledge. I wanted to see if you guys could remember how to do one of these calculations and involve you getting the numbers with it. I want to make sure you guys have that information that you can figure this stuff out and you can get it. It's incredibly important because once you learn it, you cannot forget it. You have to be able to do all these calculations. And I know it's a lot to keep on you. That's why I keep bringing it back up. All right. So, I want to jump back into our previous discussions from Thursday.
Oh, this is so great. The bottom's not here again. Almost feel bad for him sometimes.
I do feel bad for the kid.
But then I remember he's the one that goes to go to sleep and I get back up. And sometimes you just gotta be accountable for yourself.
This is true. All right, so we'll get back into these quantum numbers.
We stopped at number 2, right?
Yep.
Okay.
Listen, I teach biology. I can talk and crack cute jokes. Not everybody process. If I had Miss Walker's job, I'd be cracking cute jokes all day.
I don't know.
Okay, so quantum numbers. So, 2 quantum numbers we talked about so far. First, principal quantum number. Second, angular momentum quantum number. These are the 2 quantum numbers we have discussed, and I've introduced you to. The next one I want to introduce you to be one of your favorites. This one. Is the magnetic quantum number. So, magnetic quantum number. This one's just like before it. It's going to be based off the one before it. So, we keep breaking it down, breaking it down, breaking it down. So, this will tell us what is it? Dog.
Man, I'll just pop it.
My phone died and I didn't plug it up.
Weapons. You're right on time.
I did. I did get my bag.
So happy you're here, dog.
Dang, no McDonald's today, right there.
By the way, nowhere in town had heavy whipping cream, so I never got to make it.
Oh! You know what time I ended
Not
up
heavy
leaving?
whipping cream? That's crazy.
I ended up leaving there at 9 o'clock.
That's like crazy.
Bro,
She took that long. And you know where half of it spent? Looking at turkeys.
Yeah, I believe that.
No turkey is good. She looked at it for, I know, an hour. And she sit and examined it. It was out.
All right, just tell us the orientation of the orbital, not the subshell, the orbital.
Imagine what the orbital is.
Shows us the column off the periodic table. You guys are going to like this. So for every one of these, it tells us that orientation. All that orientation is the underscores. So S, P, D, and F. For S, there's one orientation. For P, 3. See if you can pick up the pattern. How many for D?
5,
Wow. How about F?
7.
These are those underscores. You wondered where those underscores came from. Why does S have 1? Why does P have 3? Why does D have 5? This is where it comes from. It's all on the orientation of those orbitals. So in every one of these, there's, in the S, there's 1 orbital. P has 3 orbitals. D has 5 orbitals. F has 7 orbitals. Every one of those underscores, when we did those orbital notations, was an orbital. It has a range. I want to introduce you to the range. Just like before. It's based off the number before it. But the range. You will like this. The possible range is from the negative angular momentum quantum number, so negative cursive L, to positive cursive L. So the ranges for S, for the angular momentum quantum number, L. What is L if it's S? 0. So what's the range? Negative L to L. You gotta think of it this way. What's L? For S, 0. Let's look at P. What is L for P? 1. So what's the possible ranges? Negative L is negative 1, 0, 1. For D, what's L? What's L?
2.
2.
I knew that.
You're okay. Whenever I'm asking, you guys are used to in the orbital notations how many underscores? 5. You roll that off. This is where it's like I'm getting the looks in the room. It's like, what? I know there's a lot to keep in your mind. What's the range? Negative L starts at? Negative 2, negative 1, 0, 1, 2. So it's whole numbers from negative L to positive L. Where put that on there? Whole hashtag. If it's F, what's L?
3.
Put A. So, negative 3, negative 2, negative 1, 0, 1, 2, 3. Here's some key pieces of information to give you. First off, you are now being introduced to orbitals. Orbital. Probability area. Where? What's your customer? Piece of trash. We find the electrons. No.
You heard that.
Yes.
I'm sorry, you missed too much this morning.
We discussed the lab.
Oh, thank you, Jesus Lord.
So this is the area where we can find the electron. Remember Heisenberg's uncertainty principle. Whenever you're looking at the uncertainty principle, it's impossible to know the velocity and the position of an electron at the same time. What you're actually going to find out is on these subatomic levels, we have probability areas of where we can find these things. And that's what we're calling these orbitals. We're saying the probability, they're somewhere in this vicinity. Now something to keep in mind. You have maximum, you have a max of 2 electrons per orbital. So how many electrons can an orbital hold? 2. This is where it all gets really interesting. An s orbital. Let's do a 2s orbital. Holds how many electrons?
No, yes. No.
Look at the 2s. There's the orbital. How many? 1, 2. Holds 2. What about for 5d orbital? Holds how many electrons?
25. 10, 25, same thing.
1, 2, 3, 4, 5. 5d. This is why I bring this question up right now. It's really confusing. You have to understand the difference in the subshell and the orbital.
Is the singular one the orbital?
This whole thing in the orange is the subshell. How many electrons is in the 5d subshell?
10.
Maximum of 10. The orbitals are the dashes. So this is the piece of information that's new to you. The range of the orbitals for D. Every one of these dashes. This is the -2 orbital. This is -1 orbital. This is 0 orbital, 1 orbital, 2 orbital. Every one of these dashes, every one of these underscores, that is the orbital. How many electrons will one of the 5d orbitals hold? 2. That's the maximum. Any one of them. And this is a key. This is a really good trick question. How many electrons will a 4f orbital hold? How many will a 4d orbital hold?
2.
But that's a d and an f. Why is it 2?
That's an orbital.
It's an orbital. How many electrons will an s subshell hold? 2. S subshell. This whole thing is an S subshell. How many electrons will a P subshell hold? 6.
Is it bad to have to stay for the AP Psych test at all?
So bad. Yeah, you missed it out. This is the whole, like, first 10 minutes of class.
Alright. I'm going to give you the hardest one now, okay?
Wait, I have a question.
Yes.
Okay, so does that not have, like, a number or whatever to identify, like, principal of quantum?
Oh, no, it does. I'm so sorry. I'm so sorry. I'll forget.
What did you forget?
The magnetic quantum number, the abbreviation for magnetic quantum number is little m sub L.
Oh.
I'm so sorry. My bad. Maybe y'all.
I also have a question.
Yeah.
What does, like, the range have anything to do with it for just, like,
This is the thing, is the range is there for you to determine if 4 quantum numbers can exist. Then, off of that, it also helps you have to know the range here, because if I asked you for the 4 quantum numbers for this electron, you can give me the 4 quantum numbers. You don't know you can yet, but you can. That's where we're going to get to. Got to give you the information, then we're going to apply it, and it all
So,
comes
so I have
together.
to have the range for this to apply it to the next, okay,
Well, apply it to working the problem.
okay.
Good question.
I'm just gonna assume that it's a number line.
This is number 4. No, I didn't write it.
Start in the middle of 0 and you go forward and backward, and you figure it out.
Put
Number
number
line.
4 there, and now I'm mad.
You get the pattern. Okay. Your last one, the hardest one, stand by itself. You shouldn't struggle too much with this.
Patty cake.
Introduce you to the spin quantum number.
This is number 4.
Number 4. Spin quantum number, abbreviated with an M sub S. This.
What is up with you? You stop it. Who cares if you die? You're a computer. I'll put you in, you live.
Tells us spin of the electron. Shows place / element off the periodic table. Remember how we did those orbital notations? One pointed up, one pointed down? I preference this information for you. One points up and one points down because of the natural spin of the electrons. This is why the spin quantum number exists. You have a range of the spin quantum number. Plus 1/2 or negative 1/2. And that is it. Reason behind this. One spins one way, the other one has to spin the other way. Why are they spinning? Bless you.
Excuse me.
Reason for the spin. To overcome the natural repulsion of the like charges from the electron. This gives you all 4 quantum numbers. Before we go somewhere, I want to talk with you, and hopefully we don't end off on this, but we may. I want to talk with you off the spin quantum number of a increasingly huge, important concept. You're going to love this. Quantum
Oh, where's your mask at?
on my face,
Where's your other mask at?
at my house,
Where's your shield at?
on my
All
folders.
these different environments, like things.
I know, it's preparing me. Mary grabbed it and watched it this weekend, and then we got caught up last night hanging out with everybody, and I didn't put it back in my backpack. So I will suffer today. Quantum entanglement. This is the name of the idea, which has been proven of the connection between two electrons connected forever. This experiment happened. They took two electrons. They came out in the same area, same orbital. They sent one of these in Berkeley, California. The Berkeley University is the one that led this experiment. So they had one electron and the other university had the other electron. They flipped the spin of the electron. So flipping spin of the electron the other electron changed at the same time. So in other words, this is what happened in the experiment that shows this quantum entanglement. These electrons are entangled. They communicate without ever having the ability to communicate. It's the weirdest and strangest thing ever. I told you, this is the section I like getting to because it messes with your head a little bit. They had one electron at one university, had the other electron at the other university. They took the electron, flipped it, and made it spin the other way. As soon as they flipped it, made it spin the other way, the other university flipped. Theirs flipped. Then they could flip it back, and this one would flip. They were connected. It didn't matter. They were connected together. And you couldn't change it. And there was no way. They're separate. They weren't even, how could they communicate? No idea. But hey, dear God, you know, an electron acts as a wave. I'll look at it, it acts as a particle. It's a wave, it's a particle. Physics got weird, y'all. Okay? All right. While you're putting that away, I want to look at you and show you. Tomorrow when you come in here, we're going to start applying these. I promise you, tomorrow it's just going to be like orbital notation, electron configuration. You're going to pick it up. So this is what you're going to start seeing. So I'm going to set 4 quantum numbers up, and you'll determine whether they can exist or not. So you remember those ranges I gave you? That's how you're going to work these. Then we'll start applying these to elements. It's going to be a great fun time. Besides that, have a great wonderful day. You all will destroy your AP psychology exam. Oh.
She's the main girl on points.
Big guy. All right. So we have spent time. And we have spent them and we have learned our 4 quantum numbers. Today is all about applying what you've learned. It's all confusing to you right now because you have no idea. You're like, well, what have I learned? So the first set of problems we're going to work is if the set of quantum numbers can or cannot exist. In order to determine if this set of quantum numbers can or cannot exist, use the ranges. So, review the ranges. For the principal quantum number, n, it goes from 1 to 7, and it has to be a whole number. For the angular momentum quantum number, L, it is 0 to n minus 1, and it has to be a whole number. Bless you.
So what's this called, what we're doing now? I ain't have my paper.
This is called a review.
Okay.
And then we're going to determine if these quantum numbers can or cannot exist. The magnetic quantum number, M sub L, goes from negative L to L. Whole numbers. Then your personal favorite one that you all will love and adore. Spin quantum number. Plus 1/2, minus 1/2. Plus 1/2 if the arrow points up, negative 1/2 if the arrow points down. Plus 1/2 is in the first part, negative 1/2 is in the second part. So we get into the fun part, and it's this simple. Let's determine if these can exist. So whenever you're looking at this is how I will set this up to you.
Mr. Hall, I got a problem.
What?
I don't even know what L means. I didn't write that. Could you real quick give me a quick definition of that?
Angular momentum quantum number.
Okay.
What did you say?
Angular momentum quantum number. Angular momentum quantum number. Tells you the shape.
Quantum number.
There you go. She's got it for you.
You can't read her handwriting.
I'll give you these 4 numbers. So I'll give you 4. I'm going to go ahead and tell you this one can't exist because I'm going to make it where it can exist so you can see it. This is as simple as it gets. Start at the top, work your way down. Find if there's a problem, if that number cannot exist. The reason we stop from the top is because all these are based off the one before it. Principal quantum number has to be 1 through 7 and a whole number. Can that number exist? Why? It's not a whole number. So this right here is the problem. Can it exist? No. That simple. So, set a couple up.
You want us to write those numbers down?
You're up. Give me more room. Give you a second to write these down. I got you 5 examples up here. We're going to determine whether they can or cannot exist. It's that simple. So, Let's start at the first one and follow my lead. Start with the principal quantum number n. N is 3. Can 3 exist?
Yeah, it is.
Okay, so we're good so far. Go to L. L is -1. Can L be -1?
No,
Why?
because that's be from 0 to something else.
0 to n minus 1.
Yeah.
It's below 0, so it can't exist. You don't need to go any farther. No.
Oh, so they all have to be right?
They have to follow the rule.
Okay.
So this set of 4 quantum numbers cannot exist. Let's move to the next one. Can n be 4?
Yes.
If n is 4, can L be 0?
Yes.
Yes. Why? L is 0 to n minus 1.
N could equal 1 and make it 0.
N is 4 though, so it could be 0, 1, 2, or 3.
Same thing.
So that can exist. Go to m sub L. M sub L is 0. Can m sub L be 0?
Yes.
Do it this way. Look here. What's n? 4, right? Okay, so let's put 4. So n is 4. L. L is from 0 to n minus 1. What's n? 4. So 4 minus 1 is 3. So it has to be a whole number, so it has to be 0, 1, 2, or 3. In this case, I give you L is 0. Right? So we're looking at 0. Christmas theme. Went shopping yesterday, bought some Christmas stuff. Oh yeah, I love Christmas. Okay, m sub L. From negative L to positive L. What's L?
0.
So L is 0. So that means we can go from 0 to 0. What does that mean? M sub L has to be.
0.
What is m sub L? Okay. Now, all that can exist. Let's go here. Spin quantum number. It's -1/2. Can that be it? So, yes. That can exist. Next. Can n be 7?
Yes.
Okay. If n is 7, can L be 6?
Yes.
Yes. If L is 6, can m sub L be 5?
Yes.
Yes. Look at it this way. M sub L. Negative L to positive L. If L is 6, I can go from -6 to +6. 5 falls in there, right? So it can be 5. Spin quantum number. +1/2?
Yes.
Yes.
So is this not what things will be on the quiz? This material, what, like, on how to work this without you telling me?
I'll answer.
No,
Rule number 1.
no, not.
Once
no.
you learn it, don't forget it.
Is
Goes to
this-
rule number 2. All is fair game.
Is this as far as this goes in depth?
No.
Oh.
How come you didn't subtract from the 7 like you did from the 4 and make the 7 a 6? Like you made the 4 a 3?
I can, I just didn't do it. So like, from here, it can be 0 to n minus 1. So 0 to
okay.
n minus 1 is 0 to 6.
Okay.
I just didn't write it down.
Okay.
I'll start doing that. So this one can exist. Why? Very nice. Can n be 12?
No.
That was let's move to the next one. Can n be 5? If that means if n is 5, that means L can be from 0 to n minus 1. N is 5. 5 minus 1 is 4. You will kill the SAT. So 0 to 4. So L is 0. Does that fall in the range? Okay, so we're good there. How about here? If L is 0, M sub L is negative L to positive L. So 0 to 0. Can M sub L be 1?
No.
Nope, not a problem. How you feeling? I feel like you're starting to catch on. Like now you're starting to get it. Like, oh, that's what he meant when we covered all this stuff.
I just gotta think of the like equations.
That's how you gotta roll through it. Okay.
Mr. Hall?
Yeah.
What is like M sub L?
That's just the abbreviation of it. They do M sub L because it's based off of. All right. Let's do. You all choose me one brave soul from your class. Wow, that was fast.
Well, thank you.
Sorry, man.
All right. Let's switch.
I had to do it myself.
Doesn't matter. You got the whole class to work with you.
What am I doing?
If I give you a second, get it wrote down. Oh, I'm sorry. I'm right here. Wait a minute. Just kick me. Get out of the way. We're going to determine if these can be hit.
Oh, you don't have the ballpoint marker.
The bullets?
Yeah.
I despise those.
How?
I hate
We
them.
write so good.
No, they don't. They're trash.
No, the chisel, it's like 12 different shapes.
You know what? Sit back down. Somebody, y'all get me somebody else. I veto your election.
Y'all ready?
All right.
You ready? Okay. Can 6 be yes?
Can N be 6?
Oh, can N be 6? Okay.
Okay, if N is 6, what does that mean L can be? 0 to 5.
0 to N minus 1, which is 5. Okay, it's 4, 0 to 5.
Cross your O.
Huh?
Cross your O. It's 0
0
plus
plus
5.
5.
That's the only be 5. It's 0 to 5.
And it's 4 between 0 and 5.
Yes, it might just be.
Next.
Okay. I forgot the equation for that one. Okay. We got negative that to positive that.
So what's the range for M sub L?
Negative 4 to positive.
Negative 4 to positive 4.
Okay. There's one thought
Yeah.
between that.
8 numbers.
Nice.
Okay. Then we got positive 1 4.
No.
No, why?
Because it has a
Mr. Hall said so.
That only works in Mr. Hall. Good job. You will slay the MCAT exam. It's the exam to become a
You will
doctor.
slay the ASVAB.
No.
Knox.
No. Yes, no. Okay. Next. Can N be 8?
No.
Why?
Because why?
Because it's bigger than 7.
That's right.
Oh my God, we can count.
No, you should be a teacher.
No, I don't like kids. I only like to be teachers if I don't like older kids.
What else are you
Like
talking
college.
about?
High school or professor.
Can N be 7?
Yeah.
I don't know which one to use. Okay.
Alternate.
So,
N is
L
7.
is equal to 0 2
So what's the range?
minus 1. So what is
That's
76? Okay. Can L be 0?
Yes.
Yes,
Yes, it can. Okay. Negative 0, which is a 0, to 0. Can that be that? Negative 1/2. Could that be that?
Oh, you know it.
Yep.
Yes.
Yep.
Okay. Can n be 4?
Yeah.
Okay. If you have 0 to n minus 1, which is?
3.
Oh my God, good job. Can L be 2?
Yeah.
Okay. Oh no, that's wrong.
That's okay.
Okay, what's the next letter? Can M sub L be that?
Yes.
Yeah.
Okay.
You elected him.
Can that be that?
Yes.
I should.
I don't write cursive. I like to do it once in a while. Can M be 5? Okay. 0 to n minus 1. What's n minus 1? 4. I was about to say 6. Can L be that?
Yeah.
Yes, it's between 0 and 4.
Good job. Oh, that's an L.
You really got a friend who took an L.
Oh, I did. Oh, can M sub L be that?
Yes.
Yeah. What's up? Can that be that? So I'm gonna do.
What is that?
It says Jeff.
Yes.
No, it says cat.
Yes, again.
It's a T.
No.
Real good tea, Jeff.
It's a very squibbly
Alright.
Y.
How y'all feeling with this? Feel good? You ready?
No.
Okay,
You're
let's do a
going to
more
determine
conversion.
if the numbers exist. That's it.
Give me hand sanitizer right here.
They want his
Or
sanitizer.
You touched my marker. You're so scared of it.
No, because yeah,
Mr.
sorry.
Hall's got
That's
candy.
it. No, because I got super marker juice all over me.
Cry baby.
Thanks.
That's it.
Thank you for giving us
Here's
support.
the thing. This is where it gets different. That's to determine if they can exist.
I like my tea, Andrew. That's a good tea.
So you have to be able to use the range to determine if or if not they can exist. That's one set of problems.
See, now it's going to get where we don't.
Now I'm going to take you to the second one.
Oh, no.
Second one,
Notation.
Mole
We
conversion.
don't have to.
Average atomic mass. I bet it's on here.
I wish we had some math on
I
there.
forgot what that thing. What was that thing called where you used
That
post
is math,
constants and
Mr.
stuff?
Hall.
Yeah, we subtracted and added.
Yeah, you're plugging
And we
in
even have a
numbers
range.
into the equation.
Yeah, let's do light equations.
Yeah, those are fun.
What's the probability of me coming in a room and turning the light on?
1/2.
A really cool thing, we covered it in science in college about Heisenberg's uncertainty principle. There's actual equations you can work out. So my professor looked at me and he said, "Am I in here teaching?" We all went, "Yeah." He's like, "But I'm also in the geology room teaching geology." You know, what? So we were all freaking out. He said,
Everything's always a 50% chance.
"Let's do the math." So we calculated it out, the probability at that instant, him in the classroom over there teaching geology. And there actually is a number to it.
Well, I mean, if you think about it, technically everything has a 50% chance of happening, so we should just get rid of prop stacks. It either happens or it doesn't.
Oh God, if y'all bring that in, Miss Oliver, right?
I have her next period.
Even
Everybody
Miss Cole
walks in
said
and
she
show her
doesn't
that's
like-
our new
She'd kill me.
Even Miss Cole said she doesn't like problem stat. Like,
It's
statistics. If Miss Cole doesn't like it, then it has to do that.
It is.
She said it takes too long to do.
Mama said prop stats is devil.
All right. Determine the 4 quantum numbers. Y'all guys are going to like this.
No, we don't.
In order to do this, I need you all to do me a favor. I'm going to put your skills to the test.
Don't do that.
I don't have those.
As an test or an ACT test or an SAT test.
That's why Owen's scores haven't come back yet.
How's that
They ain't
yours?
come back yet.
Have you checked?
Check every day about 6 times a day.
That's me with life grades.
Give me the orbital notation.
They didn't know what to do. There was no grades in that.
Of atomic number 52, tellurium.
What?
Z equal
It's
52.
Give me the orbital notation for it. Hopefully you remember which one's orbital notation, because guess how Mr. Hall's going to ask you on your quiz.
Okay.
Give me the orbital notation.
Oh no. I'm gonna guess.
Oh no! Our table! It's broken! What's noble gas configuration? I probably need to know that.
I don't have enough confidence to just write it and
Oh,
assume
no.
I'm right.
Oh no! I don't know it!
Can Mr. Hall help you? The orbital notation is the one with the underscores and the arrows.
See, that's what I thought, but I didn't do it wrong.
Long process.
Well, where is my periodic table?
Yeah, where's our periodic table? Oh, this
Y'all need a new one?
I was supposed to do a quiz with our periodic table.
Where?
This isn't
There.
good. I can't see.
These are
You
full.
need no periodic table? Fine, we can go.
I would love one.
Me too. I'm gonna get down to
Get out of your collection.
My walls only halfway done.
Gotcha. I should have known. I'm ready for my ACT. Mr. Hall said I get a periodic table. It's alright. Look at me like.
Give.
So, Mr.
You really said
Hall,
that?
I need my periodic table.
Can you go any slower?
We all should go in and tell them that whenever we
Oh,
take
hello.
the SAT. Mr. Hall, be ready to print off a bunch of periodic tables because when we take the SAT, I'm telling them I need one or I can't start.
Can't actually use old retailer.
You know what? I know what to do to have trauma.
Thank you at my moment. One day you'll be sitting there, you know,
Trauma.
have kids, they come in, said, well, let's look at your science book. You open up your periodic table.
I can't do it. I can't do it. Get your mother.
Put it away! Five is
Can't wait till I have a kid. They come home with homework, Mary comes in. I'm being
Does work
sarcastic.
just come out of your mouth?
I'm being sarcastic.
Oh,
That
yeah.
the day when it happens, they come in and it's like math or science homework. And, you know, Mary's like, I'll help you.
Where's your periodic table?
Go see your father.
You should have one before we graduate so we can throw the baby shower.
You got jokes.
Ain't happening, man.
We'll throw you a party.
He's scared of kids. He can't even hold one.
Can you blame him?
Are you really
We'll throw you a party.
The babies is what scare me. The kids don't, but it's the babies. Depending on me for life.
He's scared of his
So,
little
we
brother.
depend on you for chemistry. It's the same thing.
But I don't have to hold
Can we admit
you,
it's not
support
quite
your
the same
head. I don't have to be like, when I lay you down, there's a proper way of laying you down, there's a proper way of picking you
There's a
up.
proper way of teaching us
but when
this
a
or we
baby's
fail
born,
this.
it's
Hey,
basically
hey,
nothing
ladies,
but
can I help
cartilage.
y'all? My wife has had this conversation with me 30 times. It ain't happening.
We need to get her in here, then we'll all protest at the
Best
same
luck with that.
time.
Can you imagine?
Then he wouldn't be able to
Can you
say,
imagine me and Dad? God help us.
No, I'm not.
Mr. Hall comes in this time next year. Well, guys, you got your wish.
I come in all sunshine and rainbows right now. If you have a kid, I come in.
I know, clear. I messed up.
The baby. It's broken. My bad.
So I know Mr. Hall just like holds it like this the wrong way and takes it up and gets in trouble with Mary. Then she'll be messaging me every morning telling him to come back home. Not asking him if he made it to work.
Just hope it doesn't have college. My little brother had college, and he literally, there's only one thing he does. Scream. I'm telling you, he was sitting screaming. He liked to be in his carrier, you know, you put the collar. But he also liked someone to rock him, so you know, we were tired, so we put him on the washing machine and turned on the toggle and set the thing on it, and he just sat there.
Oh my God.
He liked that for about 10 minutes, and then he starts screaming again.
God.
Big Milo.
At least I know that I'll never watch my kids.
It's my dad's idea.
At least it didn't go.
I survived.
Why would you not want your kids anyway? You need some.
I like babies. I love babies. I don't like kids.
I can't stand the children.
I think it's funny. My wife is excited, and she's like, "Let's have a baby." You know, she sends me all the TikTok videos of what I want for Christmas: a new dress, a teddy bear with a baby laying in the teddy bear, a new picture, and it's got a picture of a baby. And I'm like, no.
Ha ha ha, you're so funny.
Hey, it'll happen soon enough. You can't fight it.
Yeah.
You can have my little brother.
That's okay.
My mom loves
He,
little brothers.
you don't have to worry about him sporting his head. Half the time he just falls and breaks his leg. So I mean, he'll be fine.
Don't worry, we have
My little
it.
sister took a little pipe and hit him in the head with it. Like a little piece of PVC pipe.
Okay.
Hit him in the head with it and he had stitches.
Enough conversation of me having a child.
You can bring it to school every day, Mr. Hall. We take care of it.
I love y'all. That's not having a child.
Why? Dalton can be.
Because he's already got about 45.
I would be a perfect godparent.
I tell Mary all the time, it's like, you want a kid, just come to school. I got like 150.
Pick one out.
They're not the same. They don't look as
You let her
cute
walk
at
in.
Precious House.
We get paper.
You walk her in, she's like, I like that a little bit. And you're like, honey, but look over here, look at this. It's like a petting zoo.
No. That one's not good at chemistry. This one.
Then she definitely
This
would.
one can help with the laundry.
So we want not.
This one will mow the grass.
All right. So this is ordinal notation for delirium. Hopefully you got that.
Yeah.
Hopefully you got proper.
Oh my
I want to show you something to determine the four quantum numbers. How many electrons are up here?
A lot. 52.
52 of them.
Never really think of it like that.
There's 52 of them. Guess how many set of quantum numbers is up here right now?
3, 4, 52.
52. Why?
Because you
They
just.
all go
Says the
between 1 and
periodic
7.
table said so.
That's a lot of
Here's each electron.
If it wasn't a quantum number, it wouldn't exist.
Huh? Well, we know who wouldn't.
Not
have
Hunt's
this
rule.
is Mr. Hallstrong.
Not probability principle.
Wait, it's constant?
Wait, I think it's probably
Heisenberg is
I'm not really
subject.
killing that ACT right now.
Mr. Hall, you will fail the ACT.
You will second guess yourself on the ACT.
Mr. Hall.
It's not talking about principle, it is Paul exclusion principle. Elijah's right. Paul exclusion principle states what?
Where's that at? Oh my God.
No two electrons within an atom can have the same four quantum numbers. So this is an atom. These are 52 electrons. Every one of them have a different set of quantum numbers. I want to introduce you and leave you off today so you can have a 2-day vacation to come back on Friday and listen.
Is it?
We're not here for
Rock and roll.
Yeah, here Friday. Club.
Well, I guess our test will be moved to Wednesday.
No, it's still 2. What's the last electron up here?
Right there.
I don't even care.
Let me introduce you to the four quantum numbers.
And the 7 diatomic.
I want the four quantum numbers of this electron in blue. I'm dead serious.
That's crazy.
Oh, I can't wait to see this crash.
Kim took trying to say what? All right.
Huh?
N. What is N? The principal quantum number. What's the principal quantum number tell us? The energy level. So what's N here?
Down.
Oh.
5.
It's 5. What energy level is that orbital in?
Is that an S?
P.
That's a 5.
Fix it.
That looks
It looks like an S.
It looks like a 5.
That's what my files look like. Keep rolling. We ain't got time for
It
this.
looks like an S, Mr. Hall. I don't.
That is in a 5p subshell, that orbital is. So in the 5p subshell, you're in the 5th energy level.
Oh my God.
Look at L. L tells you the shape. tells you the subshell. P. If we're in a P, what does that mean L is?
We have to be.
L, S, P, D, or F. For S, it's 0. For P, it's 1. For D, it's 2. For F, it's 3.
Do what?
You just wrote so fast.
I told you, this is the one that kids struggle with to keep in your mind when we went over. The angular momentum quantum number, I covered that.
It has numbers.
Since we're in a P, that means L is
1.
Uno.
Then the range for M sub L, if L is 1, it's -1, 0, and 1, right? So let's look. This is -1, this one's 0, that one's 1. Which orbital are we in?
Negative 1.
So -1. Then, you're looking at the spin quantum number. Is the arrow up or is it down?
Down.
Which means
Positive one, negative 1/2.
-1/2.
Oh my God.
Yeah, we're gonna do that.
You know what the cool thing is?
What?
I never had to do the orbital notation, I can still give you that.
Well, then why?
Which is where I leave you on your cliffhanger. Until you return to me on Monday. I'm going to miss you all.
I'm gonna forget everything.
My heart is going to be breaking, but not my foot.
I ain't gonna.